Welcome to qnawire.
To determine whether a higher proportion of subjects in Group 1 experience drowsiness as a side effect than subjects in Group 2, we can perform a hypothesis test for the difference in proportions. The null hypothesis is that the proportion of subjects in Group 1 who experience drowsiness, P1, is equal to or less than the proportion of subjects in Group 2 who experience drowsiness. And the alternative is that P1 is greater than P2. We're using the significance of 0.05, and we can perform a hypothesis test and calculate the test statistic and the p-value. And we'll compare the p-value to alpha to make our decision. So for Group 1, p-hat is 115 out of 717. And the sample proportion from the second group was 72 out of 598. And so the standard error, well, I'll just go right to the score. The score is calculated as the difference between the sample proportions over the square root of the first sample proportion times 1 minus that proportion divided by that sample size plus the second sample's proportion times 1 minus that proportion over its sample size. And so this is 115 out of 717 minus 72 out of 598 over the square root of 115 over 717 times 1 minus 115 over 717 over 717 plus 72 out of 598 times 1 minus 72 out of 598 out of 598. And this test statistic calculates to about 2.093. And so for a p-value from a z-score of 2.093 being one-tailed because this is right-tailed, is a p-value of 0.018. And since our p-value is less than our alpha of 0.05, we will reject the null hypothesis. There is sufficient evidence to conclude that a higher proportion of subjects in Group 1 experience drowsiness as a side effect than subjects in Group 2 at the 0.05 level of significance. So that is choice B.